All right, so in this video, we're going to be looking at creating dummy variables from categorical data so that we can use those variables in our regression models. And then we're also going to be looking at some examples of some machine learning examples on a different data set, on the iris data set that is often used for machine learning examples. So for our first example, though, we're going to pull in some data that I have in an Excel sheet on movie genres. And so I'm going to import that data set. And instead of running it from the import screen, I'm going to copy and paste it into my script file because I don't want all this junk. I'm just going to call my data set data1. And again, if you haven't imported data from Excel before and you haven't used this library, of course, you need to install it from the tools menu before you do so. So then we're going to run this and import our data, and then we're going to get a look at it. And so this is the information. This data is a little old, but nonetheless, we have information about the total US gross. We have genre, distributor, and then, of course, the name of the movie. Now, we're going to try to figure out how many genres there are. So we're going to use this function unique on the genre column. And then we're going to print out the genres. And so these are the genres that are available in this particular data set. Now, we can't do a regression model, for instance, on like how much money they're making based on categorical variables. Regression doesn't work that way. We could do an ANOVA, perhaps, since we have more than two categories. But if we want to do traditional regression, what we need are convert these categorical variables into dummy variables, 0, 1 dummy variables. So the way that we're going to do that is we're going to use an if-else function that looks like so. So data1, we're going to create a new column. We're going to call it horror, since that's our first category. And our if-else function, we're going to apply it to the genre column. And if it is equal to horror, then it should be a 1, and otherwise it should be a 0. And if we run that, then if we go look at our data, we'll see there is a column here called horror, and it's a 1 if it's a horror, and it's a 0 if it's anything other than horror. And we're going to continue doing that for all of our variables, for all of our different categories of genres. So the syntax is, again, basically going to be the same. So I'm going to copy and paste a lot of this. My next one is action and action. And then the next type is adventure. And comedy. Romance. thriller, black comedy, and musical. Now, my original list, I've covered all of them except drama. I need to choose one of my categories to be the default. Um, so if all of them are zero, all of these variables are zero, then that would indicate that it's a drama. And then all of the others, they would have a one in one of the columns indicating that there's something else. But if it's none of these, then the one category I left out is drama. Actually, I also left out documentary. You should leave out one. If you over specify, um, actually this one should be, we need to make sure we're matching all of the different categories, all the category labels. So let me double check and then I'll rerun these. It'll overwrite ones that are already there if they're done. So drama I left out on purpose. Action, adventure, documentary is here. Comedy here. Romantic comedy here. Thriller, suspense, I fixed that label. Black comedy and musical. Okay, so let's all run these again. And then if we look at our data set, there's our action, adventure, comedy. Now you can scroll through the list to make sure there's at least one in each of the columns, or you can actually just add them. So for instance, if you do sum of the column black comedy, then you get, as long as you get one or more, then you're good. Now, in this case, there's only one black comedy. So maybe this is something that if we were doing a formal analysis, we would want to maybe combine with the comedy category. But I think in this case, since this is just an example, that I'm not going to worry about it too much. Before I do my analysis, I'm also going to remove the first column of the data set because it's just the movie name. And so that's not going to contribute information to the total gross because all of these movie names, I presume, are different from each other. So I'm going to extract the first column. Oops, I messed up. Okay, so I left off the one on my function and I replaced it with an old data set from another video. And so I had to go back and reload it and then rerun all of my dummy variables. But now we have the movie names extracted from the data set correctly. All right, and so from here, we're going to now there's another way that you can do this. Instead of doing this one by one, there is another way that you can automate this dummy variable process in the package parent. And we're going to use this on the distributor variable. So this is the second column of our data set. I'm going to, so this is the first column, now the first column of our data set. It was the second column. I'm also going to extract that original genre column that we've now replaced with all of these other categorical variables, all these other dummy variables. I'm going to extract the original one because I won't be able to use it in my modeling. And so I'll now have this this data set that I can work with to find to apply to my distributors. And I'm going to find a dummy variable. And that's going to be my dummy bars. That's capital V. And then I'm going to recombine this with my data. Okay, so again, we got an error because I forgot the one in my creation of the distributor variable. So I fixed that now. And so when we run the distributor function and then the dummy variables operator on that data set, then it's going to then apply that data dummy operation into our data one variable. And now we can look at the new resulting data set. And what we end up with is not only these comedies and things like that, but we also end up with these dummy variables for the various distributors. Now, I've saved this into another data set because we don't necessarily always want to do dummy variables like this. This is an awful lot of unwieldy variables in our data set. Now, sometimes we will get things where we're sort of over specifying, and this would be a perfectly good example of that. But this is an automated example of creating dummy variables for a particular column of vectors. You do see that the titles of the columns they start with the distributor name and then just tack on the name of the distributor, and they replace spaces with periods. So it is all entirely completely automated. We could have done this with the genre variable as well. And we can also just see how well it does the job if we look at these first 28 columns of the data set. There's 211 and there was 211 variables before. If we were to continue doing our regression analysis on this data, we would want to remove one of these columns, because if we include ones in all of the positions, we're actually over specifying the data. We want to have one column, one category where all of the other categories are 0, and that will be our last category. So having literally 28 columns of distributors, we would actually only want 27 of them, so that at least one of them can be 0 for all of the different categorical variables. But once you have your data converted to dummy variables like this, then we could go ahead and we could use our GLM or our LM models and construct a regression line based on those 0, 1 dummy variables. Now, we're going to then move ahead to look at some machine learning examples, just to give us a feel for some examples, and then we're going to do it on the iris data set, which is built into R. It's a common model to use for things like classification and clustering. This is not in any way going to be what we would consider a complete introduction to machine learning. We will do some of that in later videos to come, but just to get you a feel for some of the different kinds of models that we can do. So I'm going to bring in my iris data set. And we're just going to rename this so that I can refer back to the iris data set at some point if I needed it. Now we're going to split the data into test and training sets, which is often done for machine learning problems to help validate our models. We can do this with regression models as well. We have other ways of doing assessments of regression, but this is certainly one of the options that is available to us to ensure that we're not overfitting or anything like that. So we're going to create a data partition. We want our proportion to go in the training set, usually is between 0.7 and 0.8. So here I'm going to use 0.8, and then list equals false. And so that's just selecting values from the data set. And then validation is going to be selected from our data set. And we're going to subtract out the validation index. And then our testing data set is going to be just the ones, essentially our training set is just going to be the ones that were selected. And again, we put it before the comma to select the rows. Now, sometimes you'll see these referred to as, in this case, the validation index. These are the, one of these is the test set and one of these is the training set. Typically, when you choose the 80% part is going to be the training set, and the 20% part that's left will be the test set. If we actually look here at our data set, the new data set is the training set because it has 120 observations, whereas the validation set, if we go further down our list here, has only 30 observations. So that's the smaller one is the test set, and the larger one is the training set. Now, we can also do cross-validation, n-fold cross-validation. So we're going to set up an example where we're doing 10-fold cross-validation. So we're going to do train control method equals CV, that's cross-validation. And the number of times we're going to do it is 10. Now, what will happen in this case for 10-fold cross-validation, we're going to split the data into 10 sections and then take one of them to be the test set, 9 of them to be the training set, so a 90-10 split instead of an 80-20 split. And then they will repeat that for every possible combination of one set is the training set, or one set is the test set, and the remaining are the training set. And then we're going to assess the results based on their accuracy. Now, anytime you do anything that involves um, pseudo randomization, it's a good idea to set your seed in order to ensure that the results are going to be similar each time. And so I'm going to start by doing an LDA model, which is called linear discriminant analysis. And we're going to model the species from our iris data set. There's 3 of them. And we're going to model it with the rest of the 4 variables in the data set. The training data is the data set, and method is LDA. And then we're going to specify the metric to be the metric that we set as a variable, which is accuracy up here. And then we specified the training control up here as our control variable. That is this operation right here. And if we run that, then that's going to get our LDA fit. And we can repeat this sequence for some other kinds of models. So I can do rpart. I can also do KNN. I can also do SVM. Now, the issue with SVM is that typically this is a binary classifier. Ah, there we go. And then the last one that we can look at is random forest. And then we can compare the accuracy of each of these models and see which one is doing the best job. So I got an error because I forgot a set of parentheses. Yeah, so typos. So I had an extra equal sign here and I shouldn't have had one. So once you get the typing correct, then it will run properly. And then finally, we can summarize the results. And so let's look at our different examples. So LDA, we got 83% accuracy. CART got us 83% accuracy. KNN, 91% accuracy. SDM, 83%. And RF got, random forest got 91% accuracy. So our two best models here appear to be KNN and the random forest approach based on our cross-validation strategy. Now, they also give us a range of the different outcomes from the cross-validation, so the minimums and the maximums. In some cases, we got 100% accuracy, but in other cases, we got as low as 75% accuracy. So we can also create a dot plot of the results. Not there. So that we can, again, compare the models with each other. And then we can also choose whichever model we want, and we can look at the model specifically. So individual values for our tenfold cross-validation and the accuracy overall, so into one model at a time. And then finally, we can make predictions once we've chosen our best model. And again, I'm just going to use the LDA as an example. We can then make predictions on our test set, and then create our confusion matrix based on those predictions. And so in this particular example, we have 100% correct classification on our training, on our test data, which is, you know, good. Generally, what you're looking for when you build these machine learning classification models is that you want the test data to not be much lower than the training data. You can often expect that the training data, because the model is built on the training data, that it will do the best there. And then the test data is data it's never seen, and so it may do more poorly. The test data is also smaller, so sometimes you do get actually slightly better performance. But the goal is to make sure that when you're doing this comparison between the test and the training data, that in fact you're not getting much, much worse. That would suggest that your model is terribly, terribly overfit. Now, again, at some point, I will do videos that go more into each of these specific examples, but this was just meant as a kind of taste of ways that you can go beyond the sort of binary classification that we did with logistic regression and work with other kinds of data that have maybe more than two categories. We can create dummy variables for our categories, for instance, to apply binary classification to them. There are methods where we can do all of these other classification strategies that can handle more than two categories. There's lots of things out there that we are barely scraping the surface on. So this is more of a preview, not a definitive analysis. You know, so there's more to come. Somewhere down the road, we will circle back to each one of these and other kinds of not only classification models, but clustering models and other kinds of things that's in the future.